In 2007, the National Fire Protection Association reported that 22% of all fireworks injuries affected the eyes. The administrator of a local hospital claims that his community, that percentage is actually higher. His ER reported 40 eye injuries in the 154 patients who presented with firework injuries. Test the administrator's claim at the 0.05 significance level. Use StatCrunch and the p-value method. Well, first of all, we have to understand that we're testing the claim for proportion. In this sentence, it says it reported that 22% of all firework injuries affected the eyes, and that his community, that percentage was actually higher. So his claim is that the percentage is actually higher. So according to this, we're testing a proportion. So I'm going to write P, and it's actually higher. So I'm going to be greater than 22% or 0.22. So this is where our claim is. Our claim is with our alternative. That means our null hypothesis is going to be less than or equal to 0.22. And that we're going to then assume that the population percentage P sub 0 actually is 0.22. And since it's greater than, that means our alternative hypothesis that this is going to be a right-tailed test. We're also testing at the 0.05 significance level. As you can see, with your steps for hypothesis testing, we found and wrote the claim. We determined the null and alternate hypothesis. We drew the claim arrow, and we figured out the assumption and whether it's left tail or right tail. Next, because we're using the p-value method, we're going to look at the rejection criteria. The rejection criteria states that for the p-value method, we're going to reject the null if, and it's important to write p-value, not just p, the p-value is less than or equal to, sorry about that, it should be less than or equal to our significance level, which in this case is 0.05. Remember, p-value is our probability value, and our probability value, if it's unusual, if it's less than or equal to 5%. Next, our test statistic. With our test statistic, looking at our steps for hypothesis testing, since we're testing the claim about a proportion, we're going to do a z-test statistic, and it's going to be p hat minus p sub 0. So let me go ahead and write that down here for us. Our z-test statistic is going to be p hat minus p sub 0 divided by the square root of p sub 0 times q sub 0 divided by n. So substituting in those values, let's look through our sentence and gather those values. Well, we do know that p sub 0, we already wrote here, is 0.22. So we know it's minus 0.22. Q sub 0, then remember, is 1 minus 0.22. So on our calculator, let's go to that. So 1 minus 0.22 equals, and it's 0.78. So we have 0.78 is our Q sub 0. So P sub 0 is 0.22, and Q sub 0 is 0.78. So that means in my denominator, I'm going to take 0.22 times 0.78 divided by our sample size, and our sample size in this problem is going to be, let's see, it's going to be, it says his ER reported that 40 eye injuries in the 154 patients. So we're going to need those two pieces of information as well. 40 eye injuries and the 154. So this is saying that our p hat, then our sample proportion is going to be 54 out of a total of 40 out of a total of 154. See if that comes out to be a nice decimal on our calculator. 40 divided by 154, and it doesn't, so I'm going to leave it as 40 over 154. So let's see, our n, remember, is 154, and our p hat is 40 divided by 154. So on the calculator, if I have to type all this in at once, I'm going to put parentheses around the numerator and then a separate parentheses around what's inside the radical part. So I'm going to clear out my calculator and type this all in. So it's going to be 40 divided by 54. So we're taking our sample proportion minus our claim proportion, notice the parentheses, divided by the square root, and I'm going to open my parentheses and type in what's underneath. So 0.22 times 0.78 divided by 154, and close my parentheses, and then I can hit enter. So here it says our test statistic is going to be 1.19050827.9. So the parentheses are important when you're entering it in on the calculator. Graphically, this is saying, remember, this is a z distribution. And so with a z distribution, remember, it's 0, 1, and 2. -1 and -2 on our curve. And if our z test statistic is 1.19, I can label that z test statistic 1.19. This also indicates that our p-value, remember, it's right-tailed, so I'm shading the area to the right. Our p-value is the probability of it being in that region. So we can find that p-value using multiple ways, including StatCrunch. You can use it using the traditional way to get the z-values with StatCrunch, or we can do it also using our new menus. I'll show you both. The first way we can use StatCrunch is our traditional way, where we can go z, and then we can go calculators, and then our normal distribution, since it's a z distribution. And remember, this is going to be a mean of 0, standard deviation of 1. It's going to be then greater than or equal to, and then we can type in our test statistic rate. Our test statistic is going to be 1.1905827.9, and we can hit compute, and that gives us our probability value 0.1169. So it ties back into our previous chapter over normal distribution. We can also use StatCrunch in a different way. We can use StatCrunch because this is a z distribution, and remember, we do not know the population standard deviation. We can also use t-stat. So I can go stat, and then I can go t-stats, one sample, and with summary. We use this for confidence interval, but now we're going to use it for hypothesis testing. So our sample mean in this problem, let's exit out of that. We're going to cancel that. We're not testing the mean, we're testing the proportion. I apologize. So we're going to go stat, and we're going to go proportion stats, one sample, and with summary. So how did I know it's proportion stats? Remember, we said we're testing the claim about our proportion, so we're using p. So we're going to do with summary, and the number of successes here we said was 40 out of the observation, which was 154. And we're going to do a hypothesis test for p, and we're going to test the claim percentage. We're going to change the 0.5, the assumption of 0.5, to 0.22. And we also need to change our alternative hypothesis to a greater than. So we're going to perform a hypothesis test for p using our claimed proportion 0.22, and we need to change our alternative hypothesis to greater than. Then we go ahead and hit compute. I'm also going to do the optional graphs, the p-value plot, just so that you can see what this looks like. So I'm going to go ahead and then hit compute. And let's see. Okay, what information does it give us? It gives us our sample proportion count 40 over 154. It gives us also our z-test statistic. It was very close to what we calculated on the calculator, and our p-value, which we also calculated using our normal distribution. So it gives us all that information as well. So you can use StatCrunch in a variety of ways. I like this because if you hit the next arrow key here, it can give you a visual understanding, and it gives us our summary information, our z-stat of 1.1905. I just put 2 decimal places instead, and our p-value of 1.1169. So let's go ahead and finish our problem here. I'm going to label our p-value is 0.1169 on my graph. And as I said, our graph should match this graph over here. Next, our p-value, I'm going to label again as 0.1169. And according to our steps for hypothesis testing now, okay, we use StatCrunch to perform that. And let me move it up here. Step number 6 says that we reject the null if our p-value is less than or equal to our significance level. So let's look at that closely. So I'm going to take my 0.1169 and I'm going to compare it to my significance level of 0.05. If you want to, add a couple decimal places to help you see if it's less than or greater than. And we can clearly say that this is greater than. So according to this, we have to fail to reject the null if our p-value is greater than our significance level. So our decision here is going to be fail to reject the null. Now our concluding statement. Remember that this concluding statement diagram will be on your formula sheet for the test. So we have different options, A, B, C, and D. I'm going to go ahead and write them over here. A, B, C, and D. And it says, does the original claim contain the condition of equality? Remember, our original claim was greater than. It did not contain equality, so the answer would be no. We go down here. Do we reject the null hypothesis? Okay. And the answer is no, we failed to reject the null hypothesis. So that means we're going to use option D. And option D states the following. Okay, let's write it out here. The sample data. So we're using that sample data, and it does not, that's important words there, does not provide sufficient evidence to support, that's another important word, support. So basically the sample data does not support, okay, support the claim that, and remember we said his community thought the percentage is actually higher, that basically more than 22% of all firework injuries affect the eyes. And you have to state the significance level, so it would be at alpha equals 0.05. So again, make sure the fact that you make sure you set up the hypothesis, that you find the test statistic so you can find the p-value using StatCrunch, and then you decide to reject or fail to reject the null hypothesis, and looking at the chart to see your conclusion. So let's go through this again. It says the sample data does not provide sufficient evidence to support the claim that more than 22% of all firework injuries affect the eyes. So the sample data does not support that claim.